Thank you to the organizers, particularly Danny and Asaf and Abner for putting this together. So I think this started out of our visit last year. So the O'Reilly team came here thinking about doing Strata in Tel Aviv. So the timing isn't quite right for us. So I'm glad that the local team here forged ahead and did something anyway. So I'm going to talk at a much higher level. I think you'll have enough technical deep dives this afternoon. So where I'm coming from, as Asaf says, is I'm an organizer of multiple conferences, primarily Strata, but as you'll hear towards the end of this presentation, I'm actually organizing another set of conferences for O'Reilly. So my background is I was an ex-academic. I'm a practitioner. But more recently, I'm a little more involved as an organizer of conferences and as an advisor for many startups. So probably the one that you've heard of the most is Databricks, the people behind Spark. So this talk has two main parts. One, I'm going to just give you a quick overview of some technology trends, and then I'll go and sample a few topics of interest to myself and hopefully to you as well. So memory. So I think, as many of you know, memory prices continue to go down, and a lot of compute has moved to memory. But more recently, I think with the commercialization of Tachyon, I think even the storage layer might eventually move more and more into memory. Already, there are many database vendors that have bet big on memory. So related to that is the next generation of SSDs, right? So they're going to be faster, so a lot more of data sets are going to be accessible using these low latency technologies. So that's memory. So cloud. So to be honest, I was a little bit skeptical of the cloud myself, right? So a few years ago, when people were starting companies that were cloud first, so I was a little dubious about particularly enterprises moving important data sets to the cloud. But more recently, I've been talking to more and more companies, and while it's true they're not ready to move everything to the cloud, they're moving little bits of their workloads into the cloud. And you can see that, for example, with the amazing growth in the many cloud services that we're aware of, right? So Amazon in particular. But this is far from a single horse race. So if you are ever aware of, if you're ever in touch with the sales team at Azure, for example, they're quite aggressively going after Amazon, and Google is doing that as well, right? So last week, for example, at Strata, Google made a big announcement around making Bigtable available on their cloud platform. So Amazon, so this was an eye-opener for many people. So a few weeks ago announced their revenues, right? So it's tracking for this year to be a $6 billion business. So that's just Amazon. And profitable, right? So one of the things that I've noticed particularly is that more and more companies are building not just small prototypes on top of the cloud, right? So they're building actually applications. So this is just one example from Databricks, because I'm more familiar with them. So the Databricks cloud doesn't even have an official API yet, and yet there are many companies who are building actual tools and applications on top of their cloud platform. So in the case of Databricks, I think the long-term vision is to actually have an API. So they will have a platform for people to build apps. So I think at this point, there's on the order of 10 to 20 apps already on top of Databricks. And towards the end of the year, when they open up their platform, there will be many more. So the other trend is GPUs and multiple cores. So I host a track inside Strata called Hardcore Data Science. So in San Jose, we had 11 talks. So this was me and Ben Reck, the professor at Berkeley, inviting interesting speakers. And as I sat through that session in San Jose, I noticed that more than half of the talks were talking about GPUs. And actually, I'm also advising on a small startup called Graphistry that's doing visualization using GPUs. So they're able to visualize a lot more points than D3, and they can easily deploy their technologies in the cloud. So one thing about GPUs is, at least back in the old days, when you talked about GPUs, it meant you had to build your own boxes, right? So now, of course, Amazon has many instances of GPUs in the cloud. So you can easily spin up a GPU instance and actually even spin up a cluster of GPUs. So GPUs are a lot more accessible. I think they're right now much more associated with machine learning, particularly deep learning. But like I said, the visualization folks have realized that this is a technology they need to take seriously. So just closing up this thread on trends. So to the extent that even Spark people are paying attention to some of these trends, right? So they announced recently a long-term project called Tungsten, where so they're going to look at things like LLVM and OpenCL. But what's interesting is they're also going to look at CPU caches, right? So the L1, L2, L3 cache to speed up computation. So this is in the early stages, but I think they're quite determined to exploit as many of these technology trends as possible. All right, so now I'm going to kind of just do a survey of topics. So I only have a few minutes, so I can't cover everything, but these are some of the topics I'm particularly interested in and noticing that people are also interested in. So real time. So in our world, O'Reilly, so we think of real time as really the convergence of three things, right? So sensors, networks, and so those two together are interesting but really useless. So it's really big data, distributed computing, and algorithms. So make the data collected using sensors much more interesting. So there's many buzzwords in the space. I think people focus a lot on the Internet of Things, but in my world, at least, the more interesting applications that are being used in production are actually the industrial applications and the municipal applications, so industrial internet and smart cities. So for example, in Strata, we get a lot of submissions around IoT, but equally as many submissions around predictive maintenance, for example. So what's the fundamental data angle around real time? So usually people talk about event data, which is really data with a timestamp, a metric, and some entities. So, but in practical applications, the entities are usually constant, right? So at the end of the day, you're only tracking really the timestamp and the metric. So it's really just a bunch of time series, right? So, but what makes it hard is now you're dealing with many, many time series, so in the orders of potentially hundreds of millions of time series, right? So I originally came from the world of finance. There you had a few time series tracking specific symbols of derivatives or stocks. Now you have time series tracking every aspect of a data center. So there's two aspects of event data. I think the industry as a whole is very good at the first aspect, which is collecting and storing, right? So this is where distributed data stores come into play, and distributed pub-sub technologies like Kafka. So if you're interested in Kafka, Gwen Shapira is here today at the conference, so she's one of the leading experts on Kafka, and she's going to give a talk. So I think where the industry still needs a lot of work is analytics, frankly, right? So I think right now we're still in the early stages where what people are doing are basically search and simple counts. So there's early tools around anomaly detection, but there's no, I'm not seeing really good libraries yet that are generic enough to deploy into many frameworks. So I do know, for example, the Spark guys are going to start creating libraries for this purpose this year, and towards the end of the year, you'll see more of these libraries in Spark. But as far as machine learning, I think there's a few libraries here and there, but nothing that really stands out that's easy for the rest of us to use. They tend to be tied to a specific compute platform. So this is an area of intense innovation in the industry, right? So there's so many companies who want to talk to me about this space, right? So at the end of the day, like I said, they're all tackling essentially the same thing, which is how to make sense of hundreds of millions of time series. So in this slide, I kind of grouped some of these projects into 3 buckets, right? So the first set are the startups and commercial companies. The middle tier is kind of the open source projects, including the Team Apache stack, which is quite popular, a combination of Cassandra, Kafka, and Spark. And just a shout out, there is an Israeli company in this conference today called Anodot, and they're doing interesting things around time series, basically taking people who typically use graphite and helping them to scale to much larger amounts of data. So one thing that, I've noticed is that people in the space have started to combine two strains, right? So on the one hand, you have time series. On the other hand, you have network science. So it turns out that if you look at large numbers of time series, many of these time series have natural relationships, right? So if you're familiar with the particular application, so if you're managing a data center, you know that certain devices or certain software tools are related to one another. So people are building network graphs that represent these relationships. And once they do that, then they start applying network science, right? So if this particular piece of hardware fails, let's see what things around in that general neighborhood should we also be monitoring. So this is still in the early stages, but there's a lot of companies investigating whether or not they can apply these techniques to time series. So in particular, what they're doing with it is they're using network dashboards as kind of the entry point for users in order to navigate millions and millions of time series. And again, we're still in the early stages of this, right? So, because on the one hand, we have the big data people innovating around data management and analytics, but really the DevOps people are also pushing their industry forward, right? So you've got projects like Docker, CoreOS, and Mesos, and many of those people are also talking to people in our space, the big data space, to figure out how to best monitor these large data centers. So the takeaway is that data centers are going to be where many of these tools for IoT are going to emerge, I think. So here's a few. But on the other hand, I think people forget that people in industry, completely orthogonal to the people who work in data centers, are also coming up with their own tools, right? So here's a few. So in particular, GE already has a commercial offering for the industrial internet called Predix. So I just want to close by saying, so the industry is also struggling with what's the right paradigm for the Internet of Things, right? So it can't be cloud computing, right? Because you can't send everything to the cloud. That will just eat up all of the network bandwidth. So the idea here is to push more and more of the computation towards the edge, right? Particularly, a lot of these devices have compute power. So there's going to be tools like compressed sensing and algorithms that you can push to the devices. So there's no catchy term, so some people call it cloud client computing. So quickly, another topic, analytics. I'm just going to forge ahead. I don't have much time. So big space algorithms, right? So I'm particularly interested in three things, right? So you guys have heard about deep learning. Tensors, every time I write about tensors, it seems to end up on Hacker News. So I think there's a lot of interest around tensors as well. So they're higher order generalizations of matrices. But let's take just one example, deep learning. So a lot of people are aware of the applications to particularly three domains, right? So vision, speech, and text. But it has limitations, right? So you can't really apply it in domains where you need explainability or interpretability. Let's say credit risk profiling, right? So you can't apply deep learning in those spaces. But what you can do is look at what the deep learning people have done and try to figure out if you can do it in a way that overcomes some of those limitations. So one way to think of deep learning is a pipeline, right? So in each stage of the pipeline, you're coming up with better and better feature representations. So if you think of deep learning as a pipeline, well, you can probably imagine a series of tools that take machine learning and constructs pipelines that are a lot more explainable and interpretable, right? So one such initiative is from the AMP Lab, but I know the people in Intel here, particularly led by Shai Fine, also have a similar project. So what do you need in order to do a machine learning pipeline that somewhat replicates what the deep learning people have done, right? So first you want building blocks, right? So the building blocks would be the boxes in your pipeline. So in particular, you want building blocks that you can understand, right? So one limitation of deep learning is it's a black box. So take the steps of your pipeline, build primitives. So those would be your building blocks. Secondly, you need tools to piece together your primitives. So in the case of AMP Lab, they're still in the early stages. So I think what they've come up with is a simple domain-specific language to piece together the different pieces of the pipeline. So many of these ideas are already in Spark, in fact. So over time, what you want are really workflow tools so that analysts can draw simple directed acyclic graphs, right? So simple DAGs. And finally, so this is actually something that the deep learning guys don't do. You want to do some error analysis, right? So if I do a pipeline, I want some error bounds in order to make sure that I understand what the implications are of this machine learning algorithm if I deploy it in production, right? So here I'm going to take a quote from my friend Ben Lorica, right? So what their philosophy is, if we're going to put these machine learning pipelines in production in really critical applications, we need to have better error bounds. So there's many initiatives that have implemented and made deep learning usable. So I think the best one actually that I've seen recently is from the folks at Datto, right? Single box, you can do deep learning using notebooks. So I don't think you can find anything better than that right now. The Spark people are probably going to have deep learning at some point during this year, right? So I'm aware of multiple initiatives in the Spark community to bring some form of deep learning in Spark. So in fact, there probably might be a couple of talks about this at Strata in New York. All right, moving right along. So for us, cognitive augmentation is a convergence of three things: data, algorithms, and interfaces. I think us as a community, we know data and algorithms really well, but we don't pay that much attention to interfaces. So the end goal here is to take business analysts and give them data science powers, right? So to some extent, we're actually doing this inside O'Reilly, right? We have a BI team, and what we want to do is give them tools to do more and more analytics. BI, traditionally, you associate them with reporting, right? So, but what we want are analysts who can also do a little bit of the predictive stuff. So again, here's an area with many, many startups, right? So I have so many startups that talk to me about this, so here are a few. So let's just take Spark, because I'm familiar with it, right? So Spark and MLlib, the machine learning library inside Spark. So in the early days, it was mostly just data engineers, right? So I was one of the early users of Spark. You had to learn Scala, and you had to do everything using these parallel operators, right? So not user-friendly even to data scientists. So recently they made it more usable to data scientists by exposing data frames, which are just tables and SQL. And more recently, people have built on top of Spark these interfaces, so particularly these three companies. And now actually a lot of users are using Spark, business users, and they don't even know that it's Spark under the hood, right? So I talked about graphical user interfaces on one hand and code on the other, but really there's something in between. There's these DSLs, right? So domain-specific languages. So think of SQL as a domain-specific language, for example. So the idea here, and I think we're going to see this more in industry, is that if you can create a DSL for a very specific data task, let's say these machine learning pipelines or machine learning algorithms or visualization, actually business users can be trained to write some simple programs using these DSLs. And actually, this is already happening in industry, right? So for example, Trifacta has a philosophy that they're going to push people towards their elegant, beautiful user interface, but they're also going to give them the ability to write simple programs using a DSL. I got 5 minutes. So, okay, so analytics and production. So I think we're too focused on building models, but at the end of the day, we have to deploy these models in production. So again, here, I think, talk to the folks at Datto. They've made this a high priority. So their tools are still in the early stages, but they've taken this whole life cycle very, very seriously, right? So it's more than just building a model. It's actually deploying a model in production and monitoring it as well. All right, I'm going to skip all of this because I don't have much time. Here's my kind of taxonomy of tools for machine learning pipelines. So basically, as far as I can tell, there's 3 types of tools. You've got proprietary workbooks or IDEs. You've got notebooks. You've got workflow tools. And I think over time, workflow tools and notebooks are going to be related. So you build your machine learning primitive in a notebook and piece them together using a workflow tool. All right, Asaf, I'm going to just one more section. So I talk to people who build tools. Most people who build tools build generic tools, right? So horizontal solutions. I find the most interesting solutions to be actually the ones that are focused on a specific vertical, right? So in our space, there's the usual suspects, right? So everyone applies it to these areas, advertising and media. But more recently, I've been noticing more and more people are turning into 2 specific domains, right? So one is health and science. So for example, a lot of people that I know are rushing to genomics, right? So here are 3 groups, the AMP lab, Jeff Hammerbacher's lab, and a group at the University of Chicago. So here's one interesting tidbit, right? So why am I interested in genomics? Well, because some of the leading innovators in big data have turned completely to genomics, right? Here's a picture of Cloudera in 2009. So there's 11 people in this picture. 4 are completely focused on genomics at this point, right? And so Matej Zaharia, the creator of Spark, was an intern at Cloudera at that time. So he's also interested in genomics, right? So, I guess I have no more time, so I'll leave it at that. So thank you.